Hi everybody and welcome to a new exciting video in the Melody Generation with LSTM network series. Last time, if you guys remember, so we were in the process of pre-processing our folk song music dataset, and specifically we finished this function called preprocess, and we encoded the song using our time series music notation, and we saved that to different files. So we basically have here in this dataset folder a bunch of files, and each of these files contains an encoded song. So this time we continue doing work on pre-processing, and specifically what we want to do here is to basically take all of these songs and put them in a single file. So we'll basically just like collate the encoded songs from all these different files, put them in a single file, and add some delimiters. So some symbols to say, okay, so this is a song, now I have like some delimiters, and then I have like another song. So once we've done that, then we're going to create a lookup table for converting the symbols that we use in our encoding with integers that are going to be needed for our neural network. So you may be wondering, but why do we want to create a single file where we collate all the different songs? The reason is because it's going to be easier then to take that file and to manipulate that to create sequences where we can pass those sequences to the neural network for training purposes. Okay, so now let's get started. So the first thing that we want to do here is to create a new function that we'll call create a single file dataset. Okay, so here we should pass a few arguments. So the first that we want to pass is obviously the dataset path. And the dataset path is the path to this dataset folder here. Okay, then we want to pass another argument that's going to be called let's call it file dataset path. So this is just the path or the file name for our single file dataset. Okay, so since we don't have that, I can add it over here. So we can create another constant called single file dataset. Okay, and we can call this I don't know, like file dataset, right? And it's going to be saved in the current directory we're working in. Good. Okay, so let's get back here. And so what we want to do here is basically create a string where we can add all the different songs that we'll retrieve from the this like dataset folder here, right? Okay, so basically what we should do is load encoded songs and add delimiters. Okay, so this is the first thing, and then the second thing is quite straightforward. We just want to save the string, save string that contains all dataset. Okay. Sounds good. Okay, so first thing that we want to do is create a new song delimiter. So this is going to be a bunch of symbols that we'll use to say, hey, this is the end of a song. Now, when we'll move on to the next one, it'll be a new song. Okay, so for that, we're going to use a slash symbol. We're going to create an empty space, but we're not just use a single slash symbol. Rather, we're going to create as many symbols as the number of items that we want to consider in our training sequence. So here we're going to have another variable called sequence length, which we can pass in here as an argument to our create single file dataset function over here. And once again here we can create a constant which we'll call sequence length, and we'll set this up to 64. So what is this sequence length like constant? So what does it represent really? Well, so when we are training our LSTM, we need to pass some sequences that are fixed in length. Now, the important thing to understand here is that we want to use like 64 items, right? And so we want to use like the same amount of slash symbols here for the delimiter, so that at the end of a song, we're going to have an amount of delimiters, of delimiter symbols or slash symbols that are the same as the number of items that we have in a sequence. Okay, so this is the new song delimiter. And then we want to create this, not all capital letters. So we want to create a new variable that's called songs, and this is going to be our empty string, which we're going to update at every song that we'll process. Okay, so now let's load the encoded songs and add the delimiters. So for doing that, we are going to use our old friend os.walk. So we'll do for path. Here we have the subdirs, but given we're not going to have any subdirs in our dataset folder here, I'm just going to use this underscore symbol. So for path underscore and then files in os.walk, and I'll pass the dataset path. So basically what we're doing here, as we've done already in other functions in this preprocess file, so we're basically going to visit all the elements in this folder, dataset path, which is this dataset folder down here. Okay, so now we want to go through all the files in the folder. So we'll do a for file in files. Good. So now let's get the file path, because the file, this variable just has the file name of the file. So we need to get the full path, we want to do a os.path.join and pass in path along with file. Great. So now we have the file path. So now we actually want to load the song. And so here I'm going to use this load function that we haven't implemented yet, but we'll implement that in a second. And so for loading the song, we want to just pass the file path, right? So we'll load this song, and this song is going to just be a string that contains, say for example, like here we have this first song in the dataset. So, and when we load it, we'll just load all of these symbols in a single string. Okay, but obviously we need to define this load function. So let's do that up here. So we'll do define a load, and here obviously load accepts one argument, that's the file path. And so let's load this. So for doing that, we'll do a with open, open, and then we'll pass in the file path, and we'll open this in reading mode, and we'll do as fp, and then we'll do a song is equal to fp dot read, and finally we'll just return the song. Okay, so it's a very simple function, utility function that we can use generally, like whenever we need to open a song file. Okay, so here we have our song now, and we've loaded it. So the next thing that we want to do is actually append that song to our songs string, which is going to contain all of the songs together. Okay, so how do we do that? Well, we do a songs, and which is equal to songs plus we'll add the current song, and we'll add an empty space, and then finally we'll add the new song delimiter, right? Okay, by doing this, we just add the song itself and then the, in this case, 64 slash symbols. Okay, sounds good. Okay, so now at the end of these two for loops, we'll have our songs string, which contains all the songs in the dataset folder, which is good. But there's one thing that we should perfect here, is that if you look at this new song delimiter, it has both a slash symbol and an empty space, which basically means when we arrive at the end of the song string, we're both going to have a slash symbol and an empty symbol, but we don't want to have that empty symbol at the end of the song string. So how do we cut that? Well, we can use slicing. So we'll write like this instruction, which is songs is equal to songs, but we'll consider all the elements but the last one. Okay. Now we need to save the string that contains the whole all the dataset. And so for doing that, once again, we'll use with open, and this time though we have to pass this file dataset path. We'll pass it here, and then we'll open this file in writing mode, obviously, and we'll do as fp, and then we should do here an fp dot write, and we'll pass in the songs. Okay. So here we should have saved the whole string containing all the songs into this file dataset path, into like a text file that has this path. Okay, so as a final thing, we'll just return the songs. Okay, so now let's see if this works. So I'm going to be using this here. So this is like the script that we've inherited from the previous video. So I'm going to like clean a few of these things. Yeah, let me just maintain this preprocess over here, and down here I'll just create a new instruction where it says songs is equal to create single file dataset, and here we need to pass the dataset path, which is this constant. So single file, no, it's not single file dataset, sorry, I think it's called save dir, yes. So we pass the save dir, which is the path to this dataset. We then pass the single file dataset, which is the path to the single file dataset. And then we want to pass the sequence length constant, which in our case is going to be equal to 64. Okay, so now let me run the script and see if this works. And if that's the case, we should see a new file popping up here in our current directory that's called, I guess, I can't remember the name, but single file dataset. Okay, so let's see if this works. Okay, yeah, here we have it here. So let me take a look at this. Okay, so as you see, we have all the different songs, and sometimes you'll hit like this symbols over here, which are the delimiters, and if you were to count them, they would probably be 64 of them. Okay, so and here, yeah, seems to be working fine now, which is nice. Okay, but the problem with this is that, so let's just go back to this file. Okay, so if we analyze this data set here, we can find that, so we have, so this is obviously just like a long string, but so we have numbers which represent MIDI notes in our notation, but we have also a couple of other symbols that are not numbers, not integers. So we have this underscore symbol that indicates that a note has been held. And then we also have another symbol somewhere, yeah, like here, which is this R symbol that indicates a rest. Now, the problem is that the neural networks we'll be working with are not capable of just like reading strings. So they can only read numbers when they are just like reading training samples, right? Okay, so what we need to do is to create a mapping between all the symbols that we have in our data set and integers. So we want to create basically a lookup table where we have the symbols in the data set and map them onto some integers. So let's do that now. So for doing that, we need a new function, which I'll call create mapping. And this function is going to accept all the songs. And it's basically like what comes out of this create single file dataset function. So all the dataset of folk songs in a single string. Okay, so here, what we want to do really is to do a couple of things. So we want to identify the vocabulary and then save a vocabulary to a JSON file. Okay, so in other words, here we're going to create a dictionary where we're going to have this mapping, and then we'll save this dictionary into a JSON file that then we can load during the training process. Okay, so let's start by creating an empty dictionary, which we'll call mappings, and then we want to identify the vocabulary here. So what's a vocabulary in this case? Well, it's all the symbols that we have in the dataset, right? Okay, so we now know that we have, so with this songs, we basically have all of the symbols, but there's a lot of repetition of these symbols because obviously, for example, the underscore symbol is used multiple times. Same thing for 60 or for R, right? So now we just want to shrink that a list is going to be read as a list just to the symbols themselves and cut all the repetition so that we just have the vocabulary itself, just the actual symbols that we are using repeated only once, only one instance of this. Okay, so how do we do that? Well, first of all, we want to translate the song string into a list. And so this can be done quite easily because we'll do a songs, because songs is a string, and we'll use the this split method, which is going to split a string into its components. So basically it's going to have, say, for example, like in this case, we're going to have like the first item in the list being 71, then underscore, then 72. I mean, you get the idea, right? This is basic, very basic Python. Okay, so now we have a list, but it's a list with all the symbols in the dataset. So it's a lot of data, right? Now we just want to cut that to only one instance of those symbols. So how do we do that? Well, we can use a very nice trick in Python, which is the set built-in function. And so set is going to just do that for us. It's going to reduce all the symbols only to one usage, only one instance of all the possible symbols, and cuts all the redundancies there. Okay, so we'll say that we have a vocabulary variable, which is going to be equal to the list of set of songs. So what are we doing here? So we are basically casting this songs list to a set, and then we're just going back to a list, right? Once we have the set, we can go back to a list. And here we have our nice vocabulary. Okay, so we now need to create the mapping. And indeed, I forgot to put this as a high-level comment. So we should create the mapping, right? Create mappings. So how do we do that? Well, it's quite straightforward. So we'll go through all the elements of all the symbols in the vocabulary, and then we'll map that onto some integers. So for doing that, we'll do a for I symbol in enumerate, and we'll enumerate the vocabulary. Okay, and here we'll do a mappings and then symbol, and we'll assign I to each of these symbols. So we are creating new keys in the mappings dictionary for each symbol, and then we are associating to each symbol the correspondent integer. By the end of this for loop, we have our lookup table, which is really cool. So now the last thing we need to do is to save all of that. How do we do that? Well, as I said, we're going to save this as a JSON file. So what we want to do here is basically saying with, we'll do open, and here we need another like argument, another variable, which we'll call mapping path, and we'll save this. So we'll open this file in writing mode, obviously. So mapping with a G in the end. Path is yet another argument that we should pass here. Okay, so we'll do this as FP, and then we should use the JSON. So some functions which come from the JSON package. So first of all, we should import JSON. So I'll import the JSON package here. Okay, and then, yeah, let's move down. And so we'll do a JSON dot dump, and we'll pass in the mappings as well as the FP. Okay, that's cool. Okay, so this should be working now. So the only thing that's missing here is this mapping path, because obviously also like the mapping path is going to be a constant here. So let me call this mapping path, and yeah, I can just call it mapping.json. And so when we'll run this function, we should see a new create mapping function. We should see a new file called mapping.json coming into our current folder. Okay, so now let me just create a main function here. So where I'll just stick in all of this different instructions. So we'll do a preprocess, and then we'll create a single file dataset. So we'll get this songs, and then we'll create the mapping. And for that, I should pass in the songs, so the string that contains all the songs in the dataset, and pass the mapping path. Okay, so here I'll just run main. So here, let me delete this file dataset. Where is it here? Delete. Okay, delete. Okay, so let's run this and see if everything works as it should. Okay, so yeah, we know that file, we can create the single file dataset, which is cool. Now here we have the mapping. Okay, so now, the whole mapping like is correct, but that's one thing that I really don't like about this, is that everything like is only like on one line. We can fix that. It's just like to make it in a layout that's nicer and like friendlier to read. So let me get back here. So we can go in this dump function and pass in an optional argument that's called indent, and we'll put indent equal to 4. Now let me run this. Okay, so now let's see. Okay, so here we go. So this is nicer like this. Okay, so now as you can see here, so here on the left, so all the keys are the different symbols that we have in our data set. And as you can see here, we have our slash symbol as well as our underscore symbol. And here, all of these symbols are mapped to integers, which is a good thing to have, because in the next video, we're going to use our single file dataset, and we're going to use this mapping here for creating sequences that then will be able to feed into the LSTM network for training purposes. And for those training purposes, we're going to need to have like fixed sequences which have like the same length. In our case, it's going to be 64 elements or like items in the time series. Okay, so as you can see, we are slowly moving towards the cool stuff. So training the model and evaluating the model. But in the next video, we're going to be doing like our last bit of pre-processing before entering like training. And so, yeah, I hope like you are appreciating how much work it gets into pre-processing. And unfortunately, this is most of the work that you would do in probably most AI application, not just AI audio or AI music. With all of that said, I hope you really enjoyed this video. And if that's the case, consider leaving a like. And as always, if you have any questions, leave them in the comment section. And I hope I'll see you next time. Cheers.